Okay, this is module 6.1 through 6.2, 6.4, and 6.5. And understand the earlier version, the audio did not come through. I apologize for that, so I'm going to correct that right now and rework this spreadsheet. All right, here's what we're going to do. These are various time value money calculations, and there's a couple things about this that kind of need to know that. You know, I'm not super fussed whether you know how to do a couple of things here, which I'm going to explain directly. Now, 6.1 is a straightforward future value calculation. You know, here's we have $100,000 today at a 6% interest rate, and over 5 years, we want to know what $100,000 right now under these conditions will look like 5 years from now. So this calculation is pretty straightforward. It's future value, because present value times 1 plus the interest rate raised to the power of the number of years. That last part is simply that compound interest problem that we did the first week, just kind of prettied up in a nice little package here. So what you're looking at to make this turn out the way you want it to is do this by cell references like everything else. So I'm actually going to give you this one. So we're going to start with the excuse me, the present value, which is going to be this, and going to multiply that. As remember I said, it's present value times, and in parentheses 1 plus interest rate raised to the power of. So here the interest rate is this is going to be the interest rate. And to work this, remember we like to stick 1 in front, so you can just multiply it, and remember the 1 tells, you know, basically as mathematically it adds the amount to it. So do this plus the actual interest rate, which is 6%. So in the world, you know, that this would be 1.06 is mathematically is what we're doing, and we're going to raise that to the power of the number of years. So we're going to multiply this, and just like you said, is this times this times this times this times this, but this is a lot more elegant way of doing it, and so you end up with $133,823. So over 5 years at 6% interest, $100,000, you're going to gain $33,823. That's simply your future value. Now these exercises are sort of variations of this. It's the same formula. These are just going to rearrange some of the formula, and you're going to be looking at different ways of calculating it. In the case of this, here you're going to see the denominator expression. Now let me tell you this. Once upon a time, in the old days, before we had things you could get free off the internet and you could buy at Walmart in the checkout line for $5, the way to, if you went to the if you went to, say, the bank and wanted a loan, and or want to do if you were, as a financing, you're doing the future value calculations. Once upon a time, there was a book that had tables in it. The tables would simply say, have a dollar amount, usually some round figure, from maybe it's 250, 500, 1,000, 10,000, 100,000, all right. And then they would say interest rates, and they would have these standard interest rates. It's not like today where you could get something with a really kind of bizarre odd number as an interest rate. Back then, because it was a real pain in the ass to calculate, what they did was they would just be these tables. So you go to the bank, the guy at the bank says, all right, how much do you want to borrow? Here's the present value. We need to figure out what your payments are. Well, the math gets kind of furry, and remember back then you're talking about that little, like some 10 key or something. And so they did a bunch of math here that worked out to something called a denominator expression. You remember you did a numerator expression previously, and that's another way of doing the calculations. Well, here's the idea. You figure out what a denominator expression would be for a particular interest rate for a particular amount of time, and then simply all you have to do is know the denominator expression, and you can divide your denominator expression into the present value, what you're borrowing, and that tells you down to the penny how much you need to pay every month. All right, and like here, there's select monthly, annual, once. Well, since we're doing this over 12 months, you're talking about a 12-month thing. Had this been one, well, then you would have said it would have been annual, and if all of that had been left out, it would have been a balloon payment, which would just be the once. All right. So simply put, a lot of this stuff is fairly simple to put in. But remember, we're going to want to put this in by always do it by cell references. So if you want to reuse a spreadsheet, all you have to do is change your numbers here, and all this stuff just recalculates. So in the case of the periods, you're looking at how many months, and that is, you put this get off there. All right, so the equals the number of months times the number of years. Whoop, put that in the wrong hole here. Hang on. That go away. There we go. Now it's where it belongs. All right. So you calculated the number of years times the number of times during each year that you're going to make payments. So 5 years, 12 times a year, 60 periods. All right. So anytime you hear period in a finance calculation, in your mind that should just be how many times you're going to cut a check. All right. And with respect how often. All right. Periodic interest. The periodic interest is pretty straightforward, because simply your periodic interest is going to be your that's each time you make a payment during the year. All right, this is the annual interest, spelled incorrectly, I might add. You're going to do that 12 times. So how much of that interest is every time? So that's really fairly simple to do, because you're just going to take the annual interest and you're going to divide it by the number of times you're paying it, and so it's basically about 0.5% every period. But 12 times, that would be 6%, right? All right, so your interest rate expression. All right, remember interest rate expressions, they give you just 1 plus I. So to do this with our spreadsheet, again, I think it's kind of stupid to do it this way, because the unit constant is a unit constant. So I tell you to do it by cell reference, but this only happens one time, so you could put that in there without causing yourself too much problem. All right. Oops. Here I go sticking it in wrong. It's the wrong. It's not D5. It's the periodic interest. There we go. Now, so your interest rate expression, because you want to know this. You want to know this by month. Right, so every time you make a payment, because what we're trying to do here is a bunch of shorthand, so that you can divide this number, your denominator expression, into the amount you're borrowing to find out what the payment is. All right, this is the old school way of doing it, and I'm not hyper fussed whether you know how to do this. The whole point is like doing this like with Excel or the payment like you're doing on a calculator. This is so much easier, because all of this other crap is done under the hood. You never see it. You just plug in the numbers. You don't have to know how to do the math. You just stick the numbers in the proper place, and you automatically get the answer. The wonders of modern computing. All right, so your denominator expression. Now this messes with a lot of people. Now this same expression format won't work over here, because here you're talking about present value, here you're talking about future value, so you got to play with the numbers. And here you have future value and present value, so again, it's rearranging the expression. I'm going to show you how to do that. All right, first in this one, I know this really drives folks nuts, so let me walk you through this. This particular one's not that really not that difficult. This one actually literally works out the way this does. So we would say equals, and just you follow this format. Need a bracket because we're going to have some hierarchical math here. So we're going to do the, it's basically going to end up being the unit constant minus back to the unit constant divided by the interest rate expression, which, see, that's what that little, the 1 plus I. All right, so that's what we're going to do there. Raised to the power of, all right, that's the n. All right, so 1 plus I, we actually did that here. All right, and the n raised to the power of, well, the power of is the is the number of periods. How many times we're gonna do the check? So there we go. Let's get our brackets closed, and then we're going to divide the whole thing by the periodic interest, and that gives us a denominator expression of 51.73. Now all this did is we took a bunch of math that would be otherwise done up here, but made it easy to divide, to find out what the payments are by dividing. Here in the payment we go equals, it's your payment present value, the 120,000, and we're going to divide it by the denominator value. Remember, the denominator is the bottom number, and this is what we're looking for. So if we've done our math correctly, that's going to give us our monthly amount we have to budget for, $2,319.94 on a $120,000 note at 6% annual interest paid at, and you pay on it 12 months a year. All right, and I tell you that works out nicely. And since it's done monthly, you know, we want to say, yep, that's what we're doing. All right, now this, like I say, I'm not so fussed about getting this. You just kind of need to know that this is how this works. This is sort of old school. All right, future value is a pretty straightforward thing, but over here, it's plugging in these things that kind of gets you sort of need to understand a little better. And here, the future value is your expected cost. All right, the expected cost. Expected indicates that you don't know what it is, but you expect it to be that amount. Now you can really screw up pretty badly here if your estimate of what something's going to cost is significantly off. You know, nobody expects you to get it dead on, but if this gets very far off, then that makes all your other numbers pretty hokey. All right, so your expected cost in this case is your future value. All right, the rate you're going to get from the problem, and I think, as I recall, it's like 4.5% is what you end up with. The number of years, again, from the problem is 4. The denominator, now this is where it gets a little different because you have to rearrange the ratio now because you're not starting with the present value, you start with the future value. All right, so the denominator, you end up with a little different number. All right. So here's what you're going to do. We're just altering the, we're rearranging this. You know, some of us that have, you know, kind of studied back when there were dinosaurs roaming the classroom, may remember the, you know, the stuff from grade school. We learned how to rearrange formulas, and we sort of don't do that quite as much anymore as we used to. So in this case, what you're looking for is the you're going to add 1 plus the rate, which is basically the same thing that you did here in this formula. All right, so 1 plus the rate. You're going to raise that by the number of number of years minus 1. All right, because you end up with an extra year. Mathematically, you're going to end up with an extra year. So it's number of years minus 1, and then you're going to divide that by the rate. All right, and that's going to give you your payment. All right, and I'm not, yeah, whatever. I know what it is. Just haven't plugged it in. So that's the formula you're going to use, and you can plug this stuff in. That's going to be your. Apparently that clicked on there, so that actually should be in the denominator. That actually goes here. All right, payment. All right, listen, the payment formula. This is, again, it's just like this one. All right, it's going to be the denominator. This, your future value divided by the denominator. So that'll simply be the expected cost divided by your denominator, and that will, and it's going to divide by 0 because there's nothing in there to calculate yet, but that will give you this. Now, this is what this is, and we're going to prove it using the Excel formula. So you see the Excel formula works just the same way. All right, you should get exactly the same number. Now, the format is, you've done this in previous spreadsheets, but I've noticed that some people are having some difficulty with where some of these things go. All right, so the payment function calculates for a loan based on constant payments and constant interest rate. And anybody, never, ever, 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 ever do a loan on any other terms. And there are literally thousands of permutations. If they're trying to do it on other terms, they're trying to screw you, so don't do that. All right, now the payment, here are the arguments. These are always the things going there, and you leave blank anything that you don't have and just put an extra comment in there to indicate that there's something being left out. So you know what the rate is, all right? You figured that out here, so there's the rate. Next argument is is going to be the number of years that you're doing this. It's the number of periods, so that's going to be this. Then the next one is the present value. You're not given present value, so we're going to skip that. All right, and that moves on to future value, which we are given. Now, in these kind of things, like a payment or something, a negative sign, a minus sign, indicates which way the money's going. Since this money's in the future, we're going to indicate this with a minus sign. If you do not do that, your calculations are going to come up wildly off. And so that's simply the formula that you need to do. And it's a nice thing about using, say, Excel for this and using these formulas, because the formula basically tells you where your arguments go, all right? And if you've got, if there's a number you don't have, then just put a second period in there, so that acts like, you know, don't have anything here, so move to the next argument, which was the future value. Now, if you don't have a type of loan, you can leave that one blank, and it knows that, you know, but it's going to count them left to right. So anywhere you put in a double comma is going to skip an argument if you don't have it. So if this is a present value calculation like you're doing here, then it's the future value one that you would leave that, and then it's pretty straightforward to do the math. All right. Oops. So I shall leave that out. All right. Now here, I'll show you how to do the denominator here, and the rest is on you, because this one again is a little bit different because you're given a present value. All right, present value. Doing a present value in a calculation like this is pretty straightforward. A present value is simply going to be the future value divided by the number of years. So like this will be equals 3 divided by K6. Well, whoops, I got that. It's kind of hard to do this like this. Equals K2 divided by, that'll be K6, which is going to be the denominator. All right. Give it a rest, dude. Seriously. There we go. Yeah, that's right. All right, the denominator, there's a little rearrangement we're going to do here to get this denominator. And the way that's going to work, this actually is the simplest formula because we actually have we have a different level of information here. It's going to be equals 1 plus the rate, which is this, and then we just simply raise it to the power of the number of years, which is this, and then we get our denominator, and so we've already done the present values, dividing the denominator into that. So given this information, this makes this really simple to do, and you'll do the same thing with the spreadsheet function. Now the question is is that you're going to be asked whether or not you want to wait or not wait to get your dollar amount here, and the question is, if this number is not equal or better to this number, then you need to wait. All right, so there you are. That's exercise 6, 1, 2, 4, and 5 with about half of it, well, a little under half of it done for you. But like I say, I'm really not fussed how well you know the denominator expression, frankly the numerator expressions, because I really expect to use this or this. All right, if you have any problems, shoot me an email. I have had a couple of people who have got some false answers, so if it looks like you've done it right, shoot it to me and I'll make the call. All right.